Jackie.
Hi, Maureen.
Yeah.
Yeah. Welcome to the site.
Yeah.
Hey, say hello to Maureen.
Hi. How you doing?
Just fine.
Okay.
So you are coming for the global live show with Topography, right?
Yeah. You know, our survey live show is very hot in China, and we would like to see how our Z-Lab team accomplished a LiDAR survey job. Would you please introduce something about this mission?
Sure. Well, it's a 1 to 500 topography survey work for rural roadway development.
Okay.
We are now situated in Zhengcheng district, Guangzhou. And the survey zone is between two local villages here, Dengshan Cun and Xunai Cun. The two villages are actually 4 kilometers away in linear distance.
Yeah.
But there's no direct roadway in between. So the villagers have to travel a very long way by taking a very big U-turn like this to meet each other. You know, it takes almost 1 hour, even more than that, by car. Oh my God, too long time for the 4 kilometers. I mean.
But how did you know it will take 1 hour or even longer time for that U-turn?
You know, this is flight number 2. We got flight number 1 in the other part of the zone, actually in the other village I mentioned before. Here, the local government decided to develop country roads to make shortcuts for the villagers. Okay, yeah. You see here, the vertical height drop is more than 100 meters in such a small area. Just 23 hectares. But you see here, elevated and vegetated.
Okay.
So we got the job and confirmed with the employer about our technical proposal. Now we're here.
Oh, what's that about?
It's our workmate.
Okay.
It's a UAV based LiDAR system.
Okay.
This time we use a R1350 light. Look, this is scanner part. And in the back we have IMU and GPS modules inside. The scanner measures 500,000 scans per second, and its maximum measuring range is 1,350 meters. A very powerful one. I mean, the measuring accuracy is 5 to 10 millimeters. A very powerful one with single beam, multi-echo technology, and remarkable measuring range, right? And then the GPS and IMU module will help us to record aerial positioning information, as well as the mobile carriers orientations of the UAV mobile carrier, right? Orientations like pitch, roll, and heading. And of course, different levels of IMU will provide different grades of accuracy, right? That's why we better find high quality IMU to match this high precision scanner. When all these 3 sensors are integrated into a LiDAR system, I mean like this one, we can expect the laser point cloud accuracy around 10 centimeter at 300 meter flight altitude. The other sensor will be the camera. Sometimes inbuilt, sometimes attached.
Yes.
Okay. Normally we use a smaller LiDAR, R250. R250. Yeah. But this time we use the bigger size one with another hexacopter. Also, the drone is bigger, right? With this drone, we can carry the bigger size LiDAR and fly around 45 minutes.
Oh, excellent.
So we can enjoy longer endurance, bigger coverage, and higher efficiency.
Okay.
Yeah.
So is this model carried with other career performance platforms?
Now it goes with multi-rotor, and it can be also working with VTOL fixed wing. Right? And then still manned aircraft like helicopter.
Yeah.
Then number 4, SUV-based automobile mode
Yeah.
is possible too.
Okay.
Yeah. Okay. Okay. Let's
Oh,
keep
okay.
away.
Okay. Okay.
I think it's almost ready to fly.
Whoa.
Keep it away. Just get here.
Okay. Woo.
APL above ground level will be 250 meters.
Yeah.
With flight number 2, we can capture all of the area.
Oh, okay. Yeah. So, like our slogan, fly or drive, map 3D map.
You're right.
Okay.
You know it.
And many people want to know the output accuracy. So, what's your idea about it?
It's a good question.
Yeah.
Yeah. Well, first of all, the precision and accuracy of the laser scanner should
Yeah.
count.
Yeah.
With the Regal single beam survey grade sensor, we can expect 1 centimeter in accuracy. And then the IMU, the
Yeah.
quality of IMU and GPS module and the system integration are very important. The integration techniques will lead to some system errors, more or less. Yeah, then affect the output accuracy. Yeah, that's why the system calibration by the factory is a must. Still, the fly altitude, the fly heights result in the scanning range, scanning distance. The lower you fly, right?
Yeah.
And then the shorter distance it scans, and then the better accuracy we can expect.
Yes. Yes.
Yeah.
That's
In
it.
China, we have our national
Yeah.
standards or say specifications for different mapping scales. Against 1 to 500, there should be at least 16 points per square meter. And then for 1 to 1000 scale, there should be at least 4 points per square meter.
Ah. I see.
So it depends. You know, here you see the convex terrain here,
Yeah,
right?
yeah.
Elevated and vegetated. Everybody knows that it's hard to obtain a high pond density
Yes.
in such an area. I think it's also difficult for other survey methodologies, right? Pond density is another critical one. The more true and accurate ground points we can collect, the better ground surface we can reconstruct. And then finally, the manual intervention in the post-processing, like pond cloud classification and vectorized mapping, will inevitably cause further errors. So experience means a lot more in this section. Yeah.
Okay.
Well, back to the topic. Basically speaking, the output accuracy of LiDAR survey is closely related to all the 5 factors mentioned before.
Yeah.
Yeah. And normally we say LiDAR survey brings us centimeter level accuracy. Sometimes 5 to 10, and sometimes 10 to 20, or even lower, depends. So we have to see case to case. Yeah. But when you expect, when you expect both accuracy and efficiency, I think LiDAR would be a very good option.
Yeah. Yes.
Oh, Jackie, are you okay? Okay. Sorry. Ah, terrible. Sorry. Let's say sizable area,
Yeah.
difficult terrain, and then accurate data. Go fast. No better option but LiDAR.
Oh, fantastic. Seems that LiDAR is very powerful in the survey work. So, do you think LiDAR is the best equipment in geospatial industry nowadays?
Fantastico.
Yeah.
It's a funny question, Marine. I like it. According to me, there's no the best equipment in the
Yeah.
absolute sense, but there is always the best solution to a specific case. So when the most cost-effective solution
Yeah.
can balance your time, balance your cost, and satisfy all the job needs, we'll say it's the best solution for this job, a
Yeah.
particular job. Okay, you know, upon a new survey job, we need to look into several issues.
Yes.
Yeah, before we go, or before we do the job, right? Such as let's say accuracy expectation,
Yeah.
output demand, and then submission deadline, and yeah, terrain conditions, of course,
Sure.
and blah 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 blah. Look, the drone is passing overhead, and the LiDAR is capturing data in its mission. Some survey jobs will be in the city,
Yeah.
in the town.
Yes.
Most probably, you take total station or RTK or terrestrial laser scanner or other equipment, because you can access to most of the places you wish, right?
Yeah.
But what if you are going to challenge those inaccessible areas with dense vegetations, right? In the high mountains and hills, this and that, right? It's terrible, not easy, right? And your clients always call and push, quick result, quick data,
Yeah.
right?
Yes.
And still they demand highly accurate DEM, contours, vectorized map, and even offer photo. What will you do? What do you think? It's not easy. So, no better option but LiDAR, I think.
Yes. Yes.
Uh-huh.
Yeah. You're right. You're right.
When we got this job case, you see the complex terrain here, right? It's hard to climb the mountains. Just now I even slipped, right?
Yes.
Yeah. It's hard to go inside the forest to do the work, and then it's hard to obtain RTK fixed solutions under the dense canopies. Here is bare, it's easy, but would you like to climb up, right? It's hard to collect sufficient data against 1 to 500 mapping scale.
Obviously.
Yeah.
Yeah.
Wow, not easy, man. And then, so when you take a job like this, yeah, easy job not for you, right? Difficult job, 어떡해 친구야. So no better option but LiDAR. You know, the laser scans, I mean from the LiDAR, from the laser scanner. The laser scans help us to penetrate between the gaps of the gaps between tree branches and leaves,
Yeah.
and then reach the ground and obtain the ground points data,
Good.
true and accurate.
Whoa. Excellent.
And then, you know, just in a single day, right? We came this morning, right?
Yeah.
We came this morning, one fly there, one fly here. We almost finished. We finished the data capture, right?
Yeah.
In my word, short but sharp.
Yeah.
I mean, short time
Yeah.
but sharp data.
Yes. Yes.
Hey.
You're right.
Can you imagine? Can you imagine how long it will take to do ground survey in the forest with RTK? Can you? Much longer, I'm sure.
Yeah. You're right. You're right. with LiDAR assistance, we are able to deal with more challenging work. It's very efficient. And but what if buyer's team cannot handle the hardware operations or software processing even after the training program?
Yeah, minor steps.
Oh, thank you. And it's not easy to learn or remember all. And it's common to everyone, right? So, what do you think?
I can't agree more. Yeah, it's not easy to learn at the beginning.
Yeah.
Actually, that was one of the most frequently asked questions from our clients. When we capture massive data from fieldwork, right? And do much faster compared with ground survey.
Yes.
I think we do need some time, right? We do need some time in the post-processing, right? And I believe it's a fair game, isn't it?
Yeah.
Yeah. LiDAR using remote sensing technology, unlike ground survey, measuring point by point, right? LiDAR using remote sensing technology collects trillions or even zillions of points all together.
Wow.
Yeah. Big number. So all those points, how to? Some points are wanted, like the ground points.
Yes.
But some are not, like the vegetation or buildings, right? So we have to classify the point cloud and remove all those unwanted points, right? That represent the ground objects, right? Like the cars, it's moving one, right? It doesn't represent the earth.
Yes.
And some points represent the trees, vegetations, and those buildings, right? After we remove all of them, and then we can generate the highly accurate DEM and contours, right? On the other hand, the laser grammetric vectorized mapping is a bit labor intensive.
Yes.
Yeah, and I'm sure you need some time. You need to learn. You have to learn and spend some time on it, right? Invest some time in it. Yeah, maybe some beginners will feel it difficult, hesitant to buy. Yeah, they say, wow, your workflow includes several steps. Several steps, this and that. How come? How to? Okay, right? Quite some buyers think like this, and they show us their worries. You know what we did? You know what we did? You know?
Show me, please.
Since we have plenty of survey jobs here and there, home and abroad, right? We would invite our clients to the sites.
Yeah.
Maybe in China or maybe overseas. It depends on the distance and depends on the schedule. We'll get them into our actual LiDAR survey work, right? Going with our experienced fieldwork team, they may easily understand more about how to challenge different terrains and conduct the entire workflow with us, right? And suppose they could stay a bit longer with us. We may even guide them. We may even guide them and show them how to process the data and generate the results as desired by the employer, right? No simulation. No simulation, but all reality. 100% hardcore.
Good.
So, is it more practical for them to learn? What do you think?
Yes, it's a good idea, feasible and practical, as we do have plenty of survey services running in the year. Another thing, most of people are interested to know how to verify your output accuracy and prove your results for acceptance.
Good question again, Marianne. In principle, you just use an old methodology to verify the results from the new, like what we did a couple of years ago, using total station to check GPS results. Look.
Yeah, I see.
What they are doing about?
One of them is doing article survey, and the other is taking pictures. I remember one told me that we don't need any ground control points in LiDAR survey, but why your team doing such measurement point by point?
Correct. They are doing article survey point by point. Yes, but such measurements are mainly considered as checkpoints in our workflow. In other words, they are not gonna be used as type points and improving the final output accuracy in the way of photogrammetry. So we just use them to compare in our laser point cloud. As long as the laser point cloud is okay, no problem, accurate enough, so we may expect very nice output, because all the outputs will come from the raw data. Raw data is the fundamental of all upcoming approaches. For your information, we managed to achieve the accuracy expectation and satisfy the job needs in the past few years from our jobs. A lot.
Okay. Could you please tell me more about the past job cases, Jackie?
Okay. China is our home market.
Yeah.
Right? So we receive survey service inquiries from time to time here.
Yes.
And South Group is trying every best to transform from a survey equipment manufacturer and a GIS solution provider to a geospatial data engineering and application specialist. Apart from the routine operations in China, we also got some survey jobs in the foreign countries like Cambodia, Malaysia, Indonesia, Myanmar in Asia, and then also some in Africa like Cameroon, Benin, blah 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 blah. So we are proud of our field proven solutions and project-based learnings. Well, such LiDAR survey jobs include topography, cadastre, power lines management, forestry investigation, roads scanning for SBU survey or asset inventory, and blah 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 blah. Plenty more. Come on.
Jackie, you're quite an expert in LiDAR survey now.
Not really, but thank you, Marine. But I'm sure we have so many experts in the Z-Lab team. They know much more than I do. You know why? Because they're always in honeymoon.
Honeymoon.
Yeah, honeymoon with a number of product studies and deep applications. I mean, site knowledge and project experience, job experience, right? Site knowledge and job experience help much better in the actual survey work compared with the goddamn textbooks or user manuals, I suppose.
I believe our Z-Lab team did a very good job. Practice makes perfect, and time will tell.
Yeah, exactly. I can't agree more. Rome was not built in a day, right? Not about the epidemic. And the existing team building from us results from years of continuous hard work. Thanks to the top management I mean, thanks to the support from our top management and also the support from our dear clients, we got so many opportunities to practice, to learn and see. So you came late, we almost call it a day.
Yeah, what a pity. I came so late and it's already the end of the job. I have a question. How long will it take for our ZLab team to submit all the deliverables?
Deliverables.
Yeah.
That's the key. You see here, 23 hectares,
Yeah.
almost 90% vegetational cover. I mean, we don't have a lot of ground objects to vectorize and put into the map. According to my experience, our colleagues need maximum 2 days for the point cloud classification, DEM generation, and orthophoto map production. Still, they need another 2 days for the vectorized mapping. Those small size, quite a few ground features to be presented and vectorized against 1 to 500 mapping scale, right? Let's say also 1 day here. So in total, within 4 to 5 days, we can complete all. That's
bravo! One more question. Many clients even asked me before whether we could provide a data processing service individually.
So you mean? Excuse me.
It's okay.
喂，对，我们在现场，差不多搞定了，放心，可以的，没问题。好 ，OK，拜拜。It's from the client.
Pushing you, all right. Okay. The question is provide the data processing service. Yeah.
Okay. Yeah. So my answer is yes, possible. Actually, we started this type of service before.
Okay.
Some of our colleagues used to work in the professional data processing service companies committed to laser point cloud applications for quite long. Some of them with 10 years and some of them even nearly 20 years. So I'm sure we got a very capable team to handle the data. In my word, our colleagues are really side genius and data monsters, you know.
Yeah, funny words, side juniors and data monsters. Another side?
Yeah. Let's see. Come and have a look.
Okay.
This is our R250, a smaller LiDAR with M600 DJI matrix.
Okay.
Usually we call it a star LiDAR solution. We take 2 sets here, one for sender capture, another set for backup or practice. Okay. Suppose the area size is small, we will capture two groups of data. And then we compare the accuracy, we compare the efficiency, right? Sometimes fly high or low, depends, right? This is the way how we improve our, let's say, how we improve our workflow or teamwork. Okay.
Hey Jackie, over here please.
Okay, let's see something new. Hey, Marine, look. This is the point cloud we generated from the first flight. There we also got some GCPs there. Let's see. Next piece.
Okay, GCP here.
Waterfall.
What for, right? We import the GCP into the software and then we can generate the control report. From the control report, we can tell the deviations between laser point cloud and ground survey by RTK. So,
I think this is okay.
see? Below 5 centimeters.
Ah,
That's okay.
excellent. Yeah. Okay, thank you, Jackie. Thank you for your abundant information. I think I've learned a lot today.
Yeah, welcome, Marine.
Yeah.
I hope you enjoy your day.
Yeah.
Our ZLab team is always standby and ready to help.
Yeah.
But now we are ready to go home lah. Let's go back and see how to process the data.
Okay.
Right? Sayonara, camera.
See you soon, my friends.